When we have a polynomial that has irreducible quadratic factors, that means that those quadratic factors actually have complex zeros. And so we'd like to talk about complex zeros of polynomials. We have a theorem that tells us that if you have a polynomial with real coefficients, then if it has a complex zero of the form a plus bi, then we know that its conjugate, its complex conjugate, a minus bi, is also a zero of that polynomial. And this is a powerful theorem because it tells us that our conjugate zeros, or sorry, our complex zeros come in conjugate pairs. So let's apply this with this example. Find a fourth degree polynomial function f with real coefficients that has -1, 2, and 3i as zeros. So these here are telling us, not only do we know these three zeros, but because of this 3i, we know its conjugate is also a zero. So this is 3i, its conjugate is -3i. So both 3i and -3i are zeros of the polynomial that we're going to find. That means that we can write its factors. X equals -1 means that x plus 1 is a zero. And if 2, is a factor. If 2 is a zero, then x minus 2 is a factor. If 3i is a zero, then x minus 3i is a factor. And if -3i is a zero, then x plus 3i is a factor. So this is a completely factored form for our polynomial. We'd like to write it out. We'd like to actually expand this and multiply it out. So what we're going to do is we're going to take this, this pair of factors with complex conjugates, and we're going to multiply those. Taking x times x, we get x squared. X times 3i is 3ix. -3i times x is -3ix. And then -3i times +3i is -9i squared. Well, now notice that the +3ix and the -3ix cancel. And this right here is the reason that we know that our complex zeros come in pairs, conjugate pairs. Because by having that conjugate pair, those middle terms will cancel out and we'll get rid of the i's. Okay? -9i squared is +9 because I squared is equal to -1. So when we multiply all that out together, we just end up with the factor x squared plus 9. All right, this here, the x plus 1 times x minus 2, let's go ahead and multiply those as well. We have x times x, which is x squared. X times -2, so -2x. 1 times x, which is just plus x. And 1 times -2, which is -2. Okay. We can combine these middle terms and write this out as x squared minus x minus 2. Okay, we're almost there. We've multiplied these two different pairs, and now let's go ahead and multiply all of this together. We'll take x squared times x squared. That's x to the 4th. And then x squared times 9 is 9x squared. Negative x times x squared is -x cubed. And negative x times 9 is -9x. And then -2 times x squared is -2x squared. And -2 times 9 is -18. So now we can combine some like terms. We've got our x to the 4th, our x cubed minus x cubed, and then 9x squared minus 2x squared is plus 7x squared. And then we've got our minus 9x and our minus 18. So now we have a polynomial, and it has the given zeros, and it is of degree 4.